Hello and welcome back, and in this video we are going to be multiplying and dividing rational expressions. Now, just like in the previous one, by the way, if you haven't watched my previous video on simplifying rational expressions, make sure you go back and do that now because basically everything that we're going to be talking about today is built upon that video, okay? So just like we did last time though, I want to start by showing just multiplying and dividing fractions in particular. So something like 4/5 times 3/2. How do we multiply fractions? Just a quick refresher. Well, we multiply fractions straight across. The numerators multiply each other and the denominators multiply each other. So 4/5 times 3/2 just becomes 4 times 3 over 5 times 2, which is 12 over 10. And if you watched the video yesterday, you remember that you always have to simplify. So this would become 6 over 5. Now that's just multiplying fractions. What about dividing fractions? Something like 2/5 divided by 4/15. Well, the thing about dividing fractions is it's actually incredibly similar to multiplying fractions because it actually ends up becoming multiplication. Dividing fractions, all you do is you switch the problem of multiplication and you multiply by the reciprocal of your divisor. In other words, you take what you're dividing by, you flip it upside down, and then you change it to multiplication. And then just like before, you multiply straight across, numerator times numerator, denominator times denominator, and you simplify if you can. Now, the reason I go over that is because once again, multiplying and dividing rational expressions is basically the exact same thing. So let's go ahead and take a look at a problem like this. So we have 2x squared minus 8 over x squared minus 1 times x squared plus 2x plus 1 over x cubed minus x squared minus 2x. Well, multiplying and dividing rational expressions is basically a bigger simplifying rational expressions problem. And the fact that the first thing you are going to have to do is just factor everything. So we factor everything we possibly can. So I factored the greatest common factor of 2 out of my first numerator and the greatest common factor of x out of my second denominator. And then we just factor as much as we can. So I'm going to be using a lot of different methods. We're using difference of squares, greatest common factor, factoring a trinomial. Don't forget about sum and difference of cubes, factor by grouping. All of those are going to be brought together. So as you can see, I factored everything as much as I possibly could. From here, we have to once again talk about our domain restrictions the exact same way we did in the previous video with simplifying. The only difference is we have an extra denominator to worry about. But the restrictions work the exact same way. We just set every single factor with a variable in it equal to 0 and solve and say, hey, x cannot be this number. Because if x is, say, like -1, for example, or 2 or 0, then that actually makes one or both of our denominators equal to 0, which we cannot have. So x can't be -1 from this factor, x can't be 1 from this one, x cannot be 0 from that factor, x cannot be 2 from here. And I actually already have x plus 1 listed from over here, so I don't need to list that again. So those are going to be my 4 domain restrictions. From there, we once again, just like before, cancel out all of the common factors, okay? And I'm going to try to color coordinate them so you can see exactly which ones are canceling. Because I was able to cancel out actually both x plus 1s because we had 2 factors of x plus 1 in our numerator and 2 factors of x plus 1 in our denominator. Let's say hypothetically, we had 2 x plus 1s in our numerator and only 1 x plus 1 in our denominator. We would then be able to only cancel out 1 pair. They're always going to cancel in pairs, okay? So you can never cancel like 3 in a numerator and 2 in a denominator. It's always going to come in pairs. But we cancel out every single pair of common factors amongst the numerator and denominator. And notice it can be in the same fraction or across. Notice these x minus 2's are in different fractions, but because of the way multiplication works, where it says numerator times numerator and denominator times denominator, we can cancel those out. And then just like before, we now take what our final answer is, which is just all the leftovers. We are left with a 2 and an x plus 2 in our numerator. We are left with an x and an x minus 1 in our denominator. Once again, leave that factored. It's really important, especially for once we get into graphing, to leave those factored. And then we state our domain restrictions. X cannot be 1, -1, 2, or 0. And that's it. That's all multiplying rational expressions is. Think of it as a giant factoring problem, because that's really what it is. Now dividing, I want to go into dividing. And just like before, remember, dividing fractions is really pretty much multiplying with an extra step involved, right? So that's all that's going to happen here. So for example, let's say we had this division problem, okay? Now we actually tackle this the exact same way. We're going to factor everything that we possibly can. So notice I factored every numerator, every denominator as much as we possibly could. Now, just like with simplifying and just like in multiplying, we then should take a look at what our domain restrictions are, all the values of x that make a denominator 0. So in this case, x plus 2 cannot be equal to 0, x minus 2 cannot be equal to 0, neither can 3x plus 2. And notice we have another x minus 2, but I already have that listed, so I don't need to list it again. So x cannot be 2 and negative 2, as well as negative 2/3. Now, from here, we don't start canceling things out just yet, because the division problem actually turns into multiplication. Remember how we divide fractions. You multiply by the reciprocal of your divisor. So notice I changed the division to multiplication, and I just flipped the divisor. Now 3x plus 2 and x minus 2 is in my numerator, and now 5 times x plus 3 is in our denominator. And now this is actually where an extra step comes in. You now have another denominator you didn't have before. So you actually have another set of restrictions you might have to worry about. Now that x plus 3 is in our denominator, I need to make sure that x is not equal to negative 3 as well. So you just have another step of restrictions to worry about. But from there, just like with multiplication, because now it is a multiplication problem, we go ahead and we cancel out common factors, and those cancel out factors can be numerator to denominator in the exact same fraction or diagonally, okay? Fraction to fraction, as long as it's strictly multiplication, okay? And now we take what our leftovers are, and that's our final answer. We were left with the 3x plus 2 in our numerator. We were left with just 5 in our denominator, and we state what all of our restrictions are. We can't be 2 and negative 2 and negative 2/3, as well as negative 3. And that's really it. There's really not much more to it. Okay, I'm going to go over just one more division problem just for some extra help. Let's take a look at that last problem. Notice we're going to have a lot of factoring to do, but don't worry, there's all the factors, okay? Once again, this is just 4 trinomials. Let's factor each of those. These are all the pretty simple cases where the value of a is 1, your leading coefficient is 1, so it shouldn't take you too long. Now, just like before, once you factor everything, don't start canceling out yet. Talk about your domain restrictions. I can't let x minus 10 be equal to 0. I also can't let x plus 8 be equal to 0 or x minus 7. Because if any of those becomes 0, then our denominator is 0, which means we're dividing by 0, which we just simply cannot do. That's remember where all of the domain restrictions come from. So I go ahead and I state all my domain restrictions. Okay, x can't be 10, 7, or negative 8. And now, since we factored everything and we have those restrictions, we can change it to multiplication now. Remember, dividing fractions is the same as multiplying by the divisor's reciprocal, okay? So notice I just flipped the second fraction here. And now once you have that, you should think about what your domain restrictions should be again. But notice the only new factors in my denominator are x minus 7. I actually already have that accounted for. So I don't have any additional domain restrictions just because I actually already have those listed. It's just based upon the problem. You can't know when or when not that is going to happen. It's just going to be a problem by problem basis. But since we already have all those domain restrictions, and since everything's factored and now it's multiplication, we can go ahead and cancel out our common factors. Notice we have a pair of x minus 7's cancel here, and another pair of x minus 7 cancels here. And we also have a pair of x plus 8's canceling. So all that leaves us is with x minus 3 in our numerator and x minus 10 in our denominator. So that's going to be our simplified expression with our domain restrictions of x cannot be 10, x cannot be negative 8, and x cannot be 7. And that would end up being our final answer. And that's it. So in the next video, we're going to talk about adding and subtracting rational expressions, which I'm going to tell you is more challenging. I mean, adding and subtracting fractions is something that just gives a lot of people trouble, and now we're throwing variables into the mix. But don't worry, I'm going to walk you guys through it, all right? But that's it for multiplying and dividing rational expressions. I hope this video was helpful. If there's any questions, please feel free to reach out and let me know. Otherwise, I look forward to seeing you guys in that next video.